Welcome to this presentation on the Baltic Sea bathing water quality. My name is Gerald Schernewski. I'm head of the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research in Warnemünde, Germany. At the same time, I'm professor at Klaipeda University in Lithuania. So a fast overview. I will give you some background information on the legal framework, followed by the state of bathing waters in Europe and especially in the Baltic. I will then add some case studies, indicate problems, and have a look at special pollution hotspots. We'll go on with new challenges, new organisms, and how bathing water quality is affected by climate change. And I will finish with some conclusions. A definition. Bathing waters are all surface waters in which bathing is explicitly authorized or not prohibited and traditionally practiced. This is a definition of the 1976 Bathing Water Quality Directive of the European Union. So what are potential hazards? What are causes and sources of bathing illness? You see here a lot of potential dangerous agents, organisms. But important in this respect is the probable sources. And you see that the majority is resulting from human and animals. They are most important as a source. And if we have a look at the dominant pathways, it is injection. So it means swallowing water and then getting infected. This has consequences. This means that common hazards in recreational waters are usually microbial pathogens introduced by faecal contamination from humans and animals. And this faecal contamination can result in general from four sources: the discharge of wastewater, insufficient treatment in wastewater treatment plants, sewer or septic tank breaks or overflows, open drains, and urban stormwater. But there is an alternative pathway, the direct excretion from livestock animals, from birds, from dogs at the waterside itself, or on agricultural ground, and then it's washed into the sea with rainwater. But there is a possibility of direct contamination from users and from, for example, toilet facility problems. And last not least, boats can cause problems. So the dumping of faecals from boats may be another source. So we can summarize that in general we can say settlements and agriculture are most important. And if we have a look at faecal pathogens in raw sewage, in sewage water, we can separate four groups: parasites, worms especially, protozoa, a wide range of viruses. You see adenoviruses, you see enteroviruses, hepatitis viruses. And the last group are the bacteria. We will talk about Salmonella and Vibrio later. Now interesting is Escherichia coli and intestinal enterococci. They are common in intestine or in the human body and outside the body. they usually can survive only a few days. This means they can serve as indicators for faecal contamination, especially in the aquatic environment. This is possible because they have certain properties. So they show high concentrations in sewage, in the range of millions, colony-forming units per liter. Both are relatively easy to detect. And by the way, enterococci are a subgroup of faecal streptococci. And the survival in nature of both depends on the environmental conditions. Enterococci usually survive longer than E. coli. And this means that if you sample several times and you have a look at the relationship between both, you get an impression how old the pollution is or how far the water is transported. So you can backtrack to the potential emission source. And important is that both are usually harmless. But there is a new problem. In the early 1990s, the E. coli O157 occurred in Europe. And this is not only an indicator, this can cause severe, potential life-threatening illness. So you heard about the colony-forming units. What does it mean? You take a water sample and you put this on agar, on a growing ground. And the bacteria develop piles of bacteria, colonies. And these colonies are simply counted and put into relationship to the water volume. And you see here a comparison of the two directives, the one of 1976 and the new one of 2006. And the latter is exclusively focusing on E. coli in intestinal enterococci. And between the directives, the thresholds changed. Today, we say that below 250 E. coli colonies is an excellent value, or below 100 enterococci colonies. The directive of 2006 is much more specific to faecal pollution and has, in comparison, stricter thresholds. But before, complementing parameters were taken during the monitoring. And in the new directive, the sampling frequency is reduced. It is at least once per month. But for example, in the Baltic, with a season of 4 months, it means 4 samplings for the entire season. Let's have a look at the situation in Europe. On the map, you see dominating blue bars, indicating excellent water quality. Altogether in Europe, we have about 15,000 coastal and transitional bathing waters, and about 360 in Germany, and 85% show an excellent quality. So bathing water quality is not an issue in Europe. But we will have a look at a specific region, a Baltic Sea region in Germany, Mecklenburg-Vorpommern. This gives an idea of the water quality between 2008 and 2015, the new directive, and it is focused on E. coli. Blue and green dots indicate for the large number of single beaches, non-problematic situation. But we see from time to time yellow and even red dots. This means that at least in three samples during the entire period, the threshold was exceeded. Usually, this is a result of small-scale local pollution by birds or other animals. So threshold exceedances are rare. But let's have a look how this looks for enterococci. Here you see that blue and green is even more dominating, but the red dot remains. And there is an area, the Tschetschen Lagoon, the Oder Lagoon, with more serious problems. So while in Kühlungsborn the yellow dot is simply a local pollution, the reason for the permanent exceedances of thresholds for the poor bathing water quality in Bath is not really sure. Very likely this is local agricultural discharges. But we will focus a bit on the Oder Lagoon, because the inner coastal waters, lagoons and bottoms, are more often affected by poor water quality. And this is the region in detail. The orange dots indicate important beaches. You see a lot at the Baltic Sea side, but some in the lagoon as well. The lagoon is a tourism development area. But very small, you see squares. And the squares sometimes show a red color, poor water quality. And this is especially true for the eastern part, the Polish part, where the Oder River enters. So the Oder River is transporting water to this area and causes a pollution. But we have from time to time, even on the Baltic Sea, a pollution. And, as indicated before, the area around Ueckermünde, the tourism area in Germany. This is how it looks in detail. We had a more detailed look using a hydrodynamic model with a particle tracking module that could represent microorganisms, what the reasons for the pollution in 2006 were. We considered as a source Uecker River, bathing and seagulls and fisheries, the small fisheries harbor, and cattle. At that time, cattle was still able to enter the lagoon water. The pictures give an impression how it looks at the lagoon. So when we did the model runs, we learned, first of all, that the lagoon environment, turbidity, and organic sediments in general favor the growth and the survival of E. coli. And the map shows red colors near the coast. This means high concentrations of E. coli. And a very specific situation here in the lagoon is that because of large-scale eddies, emitted pathogens are kept on the coast and are transported in a narrow ribbon along the coast. So we have always a nearshore transport with a high likelihood of threshold exceedances. In the case of 2006, our conclusion is that heavy rains that took place a few days before the sampling and the transport of pathogens after the washing off from the city and from agricultural land entered the lagoon and caused the pollution. But on this picture before, you saw that enterococci are playing an important role as well here. And they indicate long-distance transport. We think that this is a reason of large amounts of migrating birds and of the cormorant colonies. But so far we were not able to prove this. If we move to the other problematic region, the Polish side of the lagoon. And here you see that in the 2000s, the beaches very often had insufficient water quality because of the river and the large city of Szczecin. There was an insufficient treatment of the water, and this insufficiently treated water was transported to the beaches. We carried out model simulation on this as well. And on the figure A, on the top left, you see a common situation. And in a common situation, on none of the beaches, the concentrations are high enough to cause bathing prohibition. But as soon as you assume that there is a river flood with higher flow velocities, you can get some exceedances and a poor water quality at the beaches. And this is especially true when you assume, picture C now, that there is a local rain and a wash off from many places. Then, especially at the coast, you see red colors, exceedance of the bathing water quality threshold. And if both comes together, heavy rain locally and a river flood, and this is not that uncommon, you have a poor situation at the beaches. So, local emissions during heavy rain and river floods are usually responsible for the poor bathing water quality. And the problem is that climate change may increase the likelihood of heavy rains in summer and might cause problems for bathing water quality. We move to the outer coast, to Międzyzdroje on Wolin, a Polish seaside resort. And in 2008, we had a serious salmonella pollution. And this caused bathing prohibition for more than 4 weeks. So a serious problem for the tourism industry. Later, we had a look with a model. Was there really a problem? And what you see on the picture is that the salmonella, as soon as they are emitted, are usually transported, depending on the wind and flow directions, into the open sea. So different to the lagoon where everything is skewed at the coast, here there is a dispersion. And this means that, according to our model, the transport was very variable, but at the coast, apart from nearby places, there was never a real infection risk. But salmonella is still an issue in other countries as well. And we learn from it that a good bathing water quality does not mean that there is no microbial hazard. The directive only covers a narrow spectrum of potentially pathogenic agents. And another problematic example, an unknown hazard, is Vibrio vulnificus. So this is naturally present in all our coastal waters, and it can enter the body through open wounds or by eating seafood. Usually the body can deal with Vibrio. But as soon as you get an infection and this worsens into septicemia, the mortality rate becomes very high. And by the way, Vibrio cholerae is much better known, but this is a clear near relative. Problem is that we observed very high Vibrio vulnificus concentrations at single German beaches. And in the German Baltic Sea, several people died from an infection. Very likely this problem is not new. It exists for decades, but we were not aware of it. And only in 2004, when this became obvious that Vibrio might be the cause, Germany started a monitoring, and now we know better, and tourists are informed about the risk. A major problem is now that Vibrio vulnificus develops very fast as soon as temperatures, water temperatures, exceed 20 degrees. This means it benefits from shallow waters because they heat earlier in the season, faster, and usually show higher water temperatures. And they may benefit from climate change because temperatures in general will increase. And this is a very general pattern we see, that bathing water quality might be reduced because of climate change. This complex picture was put together by colleagues from the Netherlands. And on the right-hand side, you see the pluses. And pluses means this organism benefits from climate change. And most have pluses. So, many human pathogens benefit from climate change. And with increasing temperatures, new human pathogens, so-called new for our area, may enter, but they will not be detected with our existing monitoring. Our monitoring is not specific. So, some conclusions. The coastal bathing water quality in Europe is usually excellent. The European Bathing Water Quality Directive uses E. coli and enterococci as quality indicators, and they well indicate faecal pollution, but they do not reflect all microbial hazards in waters. And in the Baltic Sea, climate change seems to increase the likelihood of summerly heavy rains and floods, and subsequently may cause bathing water quality problems. And climate change will increase temperatures of the air, of the water, and this may favor new and unknown human pathogenic organisms. So, despite having an excellent bathing water quality, we need to pay attention and need to be aware of existing risks. And with this, I'd like to thank you for your attention.